Welcome back, fellow stargazers, to our continuing voyage through the cosmos. We're on a quest to uncover the celestial treasures that grace our night sky. Our targets? The enigmatic objects cataloged by Charles Messier. Messier, while hunting comets, found these blurry objects that weren't comets. They were fuzzy, diffuse, and fascinating. Little did he know he was creating a roadmap to spectacular objects in our galaxy. Prepare to be amazed, my friends, as we embark on this second part of our cosmic journey. Our first stop takes us deep into the constellation of Sagittarius, the celestial archer. Here we find Messier 23, or M23, an open cluster of stars. These stars were born from the same massive cloud of gas and dust. Imagine a cloud of hydrogen and helium collapsing under its own gravity. As it collapses, pockets ignite, bursting forth with starlight. These newborn stars form an open cluster, like a family of fireflies. M23 boasts nearly 150 members, shimmering 2,000 light-years away. Our next destination keeps us within the constellation of Sagittarius, but instead of a cluster of a few hundred stars, we're going to be looking at hundreds of thousands. Prepare to be awestruck as we journey to Messier 24, also known as the Sagittarius star cloud. It's a gap in the interstellar dust that normally obscures our view of the Milky Way's densely populated center. It provides us with a rare and breathtaking glimpse into the heart of our galaxy. This window spans an impressive 1.5 degrees across the sky, a humbling reminder that our solar system is just one tiny point of light among billions. M24 is a testament to the sheer scale and grandeur of the Milky Way. Our next stop on this cosmic journey brings us to Messier 25, or M25 for short, another open cluster residing in the constellation Sagittarius. Imagine a loose scattering of diamonds on a velvet cloth. That's the visual treat M25 offers to stargazers located approximately 2,000 light-years away from us. M25 is relatively nearby in the grand scheme of our Milky Way galaxy. It spans a region of space about 14 light-years across which, while vast in human terms, is modest for an open cluster. This cluster, like many others we've encountered, is home to a diverse array of stars, each at a different stage in its stellar evolution. Some shine with a fiery blue-white hue, indicating their youth and vigor, while others emit a cooler, yellower light, suggesting they've matured past their stellar prime. Observing open clusters like M25 provides valuable insights into the life cycles of stars and the dynamics of these loosely bound stellar groupings. As we continue our journey, keep in mind that each object we encounter tells a story written in the language of light, gravity, and the vastness of space. Our cosmic voyage now takes us to the constellation Scutum, the shield where we encounter the open cluster Messier 26, also known as M26. This cluster, while less dazzling than some of its celestial counterparts, offers its own unique story for those willing to seek it out. Discovered in 1764 by the keen-eyed Charles Messier, M26 lies roughly 5,000 light-years away from Earth. It's a relatively small open cluster, spanning a mere 15 light-years across. To put that into perspective, if our Sun were a member of M26, its nearest stellar neighbor would likely be visible to the naked eye. What makes M26 particularly interesting is the presence of a region of lower star density within its core. This void, as astronomers call it, could be a result of the gravitational interactions between the cluster's stars, or perhaps a hint at the forces that shaped its formation. Observing M26 reminds us that the cosmos is rarely uniform or predictable. It's a place of constant change, where gravity sculpts celestial landscapes and the lives of stars unfold over eons. Prepare to be captivated, for our next destination is a celestial masterpiece, Messier 27, more affectionately known as the Dumbbell Nebula. This object, located in the constellation Vulpecula, the Little Fox, is a planetary nebula, the glowing remnants of a star not unlike our own Sun. Don't let the name planetary nebula mislead you. These objects have nothing to do with planets. The term is a relic of early astronomy when their appearance through primitive telescopes resembled giant planets. In reality, the Dumbbell Nebula represents the final stages of a sun-like star's life. As a star like our Sun exhausts its nuclear fuel, its outer layers are expelled into space, creating these breathtaking shells of glowing gas. The Dumbbell Nebula's distinctive shape, resembling a two-lobed structure, is likely due to the influence of a binary companion star, although this remains an active area of research. Witnessing the Dumbbell Nebula serves as a poignant reminder of the cyclical nature of stellar evolution. What we see is a star's swan song, a final burst of brilliance before it fades into a white dwarf, a dense stellar ember. From the sprawling star clouds of Sagittarius, we shift our gaze now to a celestial artifact of a different kind. M28, a globular cluster. Imagine, if you will, a swarm of ancient stars bound together by gravity's invisible hand, a cosmic dance that has endured for billions of years. Discovered in 1764 by the keen eye of Charles Messier, M28 appears as a faint, fuzzy patch through smaller telescopes. But larger instruments reveal its true nature, a densely packed sphere of tens of thousands of stars, a glittering snow globe against the backdrop of the cosmos. These stellar swarms are not uncommon in our universe, orbiting the Milky Way like moths drawn to a cosmic flame. Each one a testament to the enduring power of gravity, holding these stellar flocks together across unimaginable stretches of time and space. Our cosmic journey now takes us from the ancient embrace of a globular cluster to the relative youth of an open cluster. M29, nestled within the constellation Cygnus the Swan, represents a different stage of stellar evolution. Unlike their densely packed globular cousins, open clusters are looser groupings of stars, often containing just a few hundred or a few thousand members. They are cosmic siblings, recently formed from the same interstellar cloud of gas and dust. This shared origin is evident in the similar colors and brightnesses of the stars within M29, a telltale sign of their shared cosmic nursery. We are witnessing, in essence, a stellar family portrait, capturing these celestial siblings in their early youth. We return now to the realm of globular clusters, this time focusing on M30, a celestial treasure residing within the constellation Capricornus, the sea goat. Like its brethren, M30 is a densely packed sphere of stars, a testament to the enduring power of gravity. What makes M30 particularly fascinating is its location within the Milky Way. It resides in the galactic halo, a region far above and below the galactic plane where star formation is less active. This suggests that M30 is an ancient structure, perhaps one of the first to form in our galaxy's long history. As we gaze upon M30, we are peering back in time, witnessing a relic of the early universe. Its stars, ancient and long-lived, offer clues to the conditions present during the Milky Way's formation, a cosmic time capsule holding secrets to our galaxy's birth. Andromeda, a name whispered in ancient myths and etched across the night sky. M31, as it's catalogued, is a vast spiral galaxy, a swirling city of stars, gas, and dust. It's the closest major galaxy to our own. Andromeda is our nearest celestial neighbor, separated by intergalactic space. Light takes over 2 million years to travel from Andromeda to us. Gazing at Andromeda, we witness light from long before our species walked the Earth. Andromeda is hurtling towards us, set to merge with the Milky Way in 4 billion years. In the grand cosmic tapestry, even the most massive galaxies often have companions, smaller galaxies bound by gravity's invisible hand. M32, a dwarf elliptical galaxy, is one such companion to the majestic Andromeda galaxy. Unlike the stately spiral arms of Andromeda, M32 appears as a smooth, almost featureless ellipse of light. This lack of intricate structure suggests a different evolutionary path, perhaps a history shaped by interactions with its larger companion. Some astronomers believe that M32 may have once been a larger spiral galaxy, stripped of its gas and dust by Andromeda's gravitational pull. Our local group of galaxies is a relatively small gathering, a cosmic neighborhood where our Milky Way resides alongside Andromeda, and a smattering of dwarf galaxies. But within this celestial cul-de-sac lies another spiral galaxy, M33, also known as the Triangulum Galaxy, a beautiful and intriguing object in its own right. M33, like Andromeda and the Milky Way, is a grand spiral galaxy, though smaller than both. Its delicate spiral arms, laced with gas and dust, are a hotbed of star formation, illuminating the galaxy with the brilliant light of newborn stars. From our vantage point, millions of light-years away, we can admire the intricate structure of M33, its spiral arms seemingly unwinding across the vast canvas of space. Imagine yourself transported to a planet within M33, gazing up at a night sky ablaze with the light of billions of stars. The sight would be breathtaking, a testament to the sheer scale and beauty of the universe we inhabit. And just as we study Andromeda to learn about our own galaxy, astronomers scrutinize M33, comparing and contrasting its properties to those of the Milky Way. These comparisons allow us to refine our understanding of galactic evolution, to unravel the complex interplay of gravity, star formation, and galactic structure. The Triangulum galaxy, though a distant neighbor, serves as a valuable laboratory for testing our theories about the universe and our place within its grand design. Our journey through the celestial catalog of Charles Messier takes us next to the constellation Perseus, and a rather spectacular open cluster M34. Now, open clusters, as we've discussed before, are like stellar nurseries, loose groupings of stars born from the same cloud of gas and dust. M34 is no exception, boasting around 100 known members scattered across a region of sky larger than the full moon. It's a relatively young cluster, too, a mere 180 million years old, practically a blink of an eye on cosmic timescales. This youthful exuberance is evident in the brilliant blue-white hues of its hottest, most massive stars. Located roughly 1,500 light-years from Earth, M34 is a treat for stargazers, easily visible with binoculars or a small telescope under dark skies. As you gaze upon this glittering swarm of stars, ponder this. Each one of those points of light represents a sun, perhaps orbited by its own retinue of planets, some potentially harboring the spark of life. Our next stop brings us to the constellation Gemini, the twins, and another fine example of an open star cluster, Messier 35 or M35 for short. Now, unlike some of the fainter objects in Messier's catalog, M35 is easily visible to the naked eye under dark skies, appearing as a faint smudge of light. But with even a modest telescope, this celestial smudge explodes into a breathtakingly beautiful collection of hundreds of stars. Imagine, if you will, a cosmic jewel box flung open against the black velvet of space, each sparkling gem a distant sun. M35 is estimated to be about 175 million years old, relatively young in astronomical terms, and lies some 2,800 light-years away from us. This places it within our own Milky Way galaxy, a fellow traveler on this grand cosmic carousel we call the Milky Way. What's particularly fascinating about M35 is its loose, almost haphazard structure. Unlike the denser globular clusters, open clusters like M35 are loosely bound by gravity, their stars slowly drifting apart over millions of years. We continue our cosmic voyage through the Messier catalog, this time setting our sights on the constellation Auriga, the charioteer. Here, amidst the tapestry of stars, lies Messier 36 or M36, a dazzling open cluster that beckons the curious observer. M36 is a relatively young cluster, a mere 25 million years old, a mere infant compared to our own 4.5 billion-year-old sun. This youthful exuberance is evident in its stellar population, dominated by hot blue-white stars that burn with an intense luminosity. Imagine, if you will, a cosmic fireworks display, frozen in time, each spark a star brimming with energy. Located approximately 4,100 light-years from Earth, M36 is best observed through a telescope, which reveals its true splendor. Under magnification, the cluster's stars come into sharp focus, like diamonds scattered across black velvet. As you gaze upon this celestial treasure, consider the vastness of space and the countless wonders that lie hidden within its depths. Our celestial journey through Messier's catalog continues with the constellation Auriga, the charioteer. Here, amidst the tapestry of stars, we find M37, one of the most densely populated open clusters visible in the night sky. Imagine a cosmic swarm, a gathering of hundreds of stars, all born from the same immense cloud of gas and dust. M37 is not just any open cluster, it stands out for its sheer abundance of stars. Over 500 of these luminous points of light have been identified within its borders, making it the richest open cluster in Auriga. At a distance of about 4,500 light-years, the light we see from these stars began its journey long before the pyramids of Giza graced the Earth. As we gaze upon this stellar nursery, Remember that each point of light represents a sun, perhaps orbited by its own family of planets. Some of these stars are similar in size and temperature to our own sun, while others burn hotter and brighter, their lives unfolding at a faster pace. The study of open clusters like M37 provides us with valuable insights into the lives and evolution of stars, reminding us that our own sun is but one member of a vast cosmic family. Our cosmic voyage through the constellation Auriga continues with a stop at another open cluster, M38. While not as densely populated as its neighbor M37, this cluster still offers a spectacular sight through even a modest telescope. Imagine a loose scattering of stars, a delicate sprinkle of diamonds on the velvet backdrop of space. Located about 4,200 light-years away, M38 is thought to be relatively young in astronomical terms, perhaps around 220 million years old. That's a mere blink of an eye compared to the age of our own solar system, which formed about 4.6 billion years ago. This relative youth is evident in the cluster's stellar population. Unlike older clusters, which are often dominated by cooler, redder stars, M38 is home to a higher proportion of hot, blue stars. These stellar giants burn bright and fast, their intense radiation illuminating the surrounding gas and dust. Over time, these massive stars will exhaust their nuclear fuel and explode as supernovae, seeding the interstellar medium with the elements necessary for the formation of new generations of stars and planets. Our cosmic journey now takes us from the celestial charioteer to the graceful constellation of Cygnus the Swan. Here, nestled within the Swan's wing, we find M39, an open cluster that, while not as visually stunning as some, holds its own unique allure. Imagine a loose collection of stars, a sprinkling of celestial fireflies against the dark expanse of space. Located about 800 light-years away, M39 is one of the closest open clusters to our own solar system. This proximity allows astronomers to study its stars in greater detail, providing valuable insights into the processes of stellar evolution. While not as densely populated as some open clusters, M39 still boasts approximately 30 confirmed members. These stars, all born from the same giant molecular cloud, are gravitationally bound, moving together through space like a flock of birds. As they age, these stellar siblings will gradually drift apart, their gravitational bonds weakening over time. Eventually, they will disperse into the Milky Way, their individual paths forever altered by their shared cosmic history. In the vast expanse of space, we often find ourselves drawn to the grand spectacles, the swirling galaxies, and the radiant nebulae. But sometimes, even the seemingly mundane can harbor a curious tale. Such is the case with Messier Object 40, or M40 for short. You see, when Charles Messier set about cataloging celestial objects in the 18th century, his primary goal was to identify objects that might be mistaken for comets. He meticulously recorded their positions in the sky, hoping to prevent future astronomers from making the same error. In 1764, while observing the constellation Ursa Major, Messier stumbled upon a faint, fuzzy patch of light that he labeled as M40. However, upon closer inspection with more powerful telescopes, it became clear that M40 was not a nebula at all, but rather a double star, two stars appearing close together in the sky. Now, this might seem like a cosmic blunder, a misclassification that should be relegated to the footnotes of astronomical history. But even in its ordinariness, M40 reminds us that the universe is full of surprises, and that sometimes what we initially perceive as one thing turns out to be something else entirely. From the subtle dance of double stars, we turn our attention now to a celestial gathering of a grander scale. In the constellation Canis Major, the Great Dog, lies Messier Object 41, a sparkling open cluster of stars easily visible to the naked eye under dark skies. Located roughly 2,300 light-years away from Earth, M41 is a relatively young cluster, its stars having ignited within the last 200 million years. Imagine, if you will, a stellar nursery, a region of space where clouds of gas and dust coalesced under the relentless pull of gravity, giving birth to a new generation of stars. As these stars formed, they inherited the motion of their parent cloud, continuing to drift through space as a loosely bound group. Over time, the gravitational interactions between the stars will gradually disperse the cluster, sending its members scattering across the Milky Way. But for now, M41 remains a dazzling sight, a testament to the ongoing cycle of stellar birth and death that plays out across the cosmos. Its bright blue-white stars, some shining hundreds of times brighter than our own sun, serve as a reminder of the immense energy generated within these stellar furnaces. From the faint whispers of double stars to the glittering assemblies of open clusters, the universe never ceases to amaze us with its boundless creativity. And perhaps nowhere is this creative force more evident than in the Orion Nebula, also known as Messier Object 42. Visible to the naked eye as a fuzzy patch of light in the sword of the constellation Orion, the Orion Nebula is one of the most recognizable and studied objects in the night sky, but its true nature is far more awe-inspiring than meets the eye. For within this vast cloud of gas and dust, spanning some 24 light-years across, a cosmic drama of epic proportions is unfolding. The Orion Nebula is a stellar nursery in overdrive, a place where intense radiation from massive young stars is sculpting the surrounding gas clouds into fantastical shapes and triggering the birth of new generations of stars. As we peer into the heart of this celestial cauldron, we are witnessing the very processes that gave rise to our own solar system some 4.6 billion years ago. The Orion Nebula reminds us that we are all children of the stars, forged from the same cosmic ingredients that continue to ignite the fires of creation throughout the universe. The Orion Nebula, a stellar nursery where stars are born, holds within it a smaller yet equally fascinating region known as M43, or de Méran's Nebula. Discovered in 1731 by Jean-Jacques Dortu de Méran, this cloud of interstellar dust and gas might seem at first glance like a mere appendage to its larger neighbor. But don't be fooled by appearances. M43 is a dynamic region in its own right, energized by a hot young star at its core. This stellar newborn, designated Nu Orionis, floods the nebula with ultraviolet radiation, causing the gas to glow and creating the ethereal spectacle we observe. As we zoom in on M43, we begin to appreciate the intricate structures sculpted by the interplay of stellar winds, radiation pressure, and gravity. Dark lanes of dust weave through the glowing gas, tracing out the ongoing battle between light and matter. These dark regions are not voids, but rather pockets of denser material where new stars may be coalescing, hidden from our view. Just as the Orion Nebula gave us a glimpse into the chaotic beauty of stellar birth, M43 provides a closer look at the intricate details of this cosmic dance. It's a reminder that even within seemingly small corners of the universe, awe-inspiring processes are constantly unfolding. As we come to an end of part 2 of exploring the Messier objects, we venture off to constellation Cancer, the Crab, where a swarm of stars awaits. This is Messier 44, a collection of roughly 1,000 stars. Even binoculars reveal why it's called the Beehive Cluster. Hundreds of stars glitter like a swarm of celestial bees. Located about 577 light-years away, it's a favorite for amateur astronomers. The stars formed around 600 million years ago from the same cloud of gas and dust. From the intricate structures of de Méran's nebula to the dazzling swarm of stars in the Beehive Cluster, our exploration of the Messier objects has revealed the breathtaking diversity and beauty of the cosmos. Each object, a brushstroke on the grand canvas of the universe, tells a story of stellar evolution, galactic dynamics, and the fundamental laws that govern our existence. But our journey is far from over. The universe beckons us to venture further, to unravel its mysteries and to marvel at its wonders. Stay tuned for part 3 of our Messier series, where we dive deeper into the cosmos, exploring more of those celestial wonders that have captivated astronomers and stargazers for centuries. Keep looking up, like, and subscribe.